Hi, welcome to this new video. This time I want to show how to use precompiled libraries inside of the Arduino IDE. And as an example, I want to show it for one of these super cheap $5 D6 Fintess trackers that you can reprogram via the Arduino IDE. And it has some heart rate sensor in the back, which you can see like this. And if I go into the menu and let it search for a heart rate, it should light up. Yes, so like this. And all this is done via a library that is published by the manufacturer of the heart rate sensor, but it's closed source, and also the library isn't open for the public. So I cannot show you where to get it, but I can show you how to use it if you have it from somewhere, and how to make it run in the Arduino IDE. And it should work for most architectures, whatever. So it should run for AVR, for ARM, and so on. So the library just needs to be compiled for the correct architecture, whatever, you know what I mean. So I have one for the ARM version 4 compiled with floating points, and the NRF52 that is used inside of the tracker has also the floating point unit, so it can perfectly run inside or with this tracker. It's not the original library that the manufacturer of the D6 tracker, so D6, uses. Some other version. Okay, that's all I got to say for now. I will switch to the computer and show you step by step how to make a new library in Arduino, how to modify the NRF52 library to accept precompiled files or have it in the compiler, and how it looks if it runs on the tracker. Okay, so I am now here at the computer, and just to show what library files or how the library files could be looking, they could have a .a ending, a .ar, or a .lib ending, but more important is how they look in the inside. So if we open one of these files, these are all the same files here, I just renamed them to show it. So if we look into them, we should see some or only one .o file and one text file. And in the .o file are the precompiled or decompiled functions and variables and everything that is needed. And in the .txt file is the descriptor for every function and in which file it is. So for example, we have in the pxerlg file for example this function or the function version, and we know it is in this file, so the compiler know where to search for the compiled function, also know in which file it has to search. If we go a step further, we could also just take a .o file and make a lib file out of it, or a .ar file, or whatever you name it. It's not so important. It's important what the compiler is searching for. And that is a story for another time. I just want to show how the library may look in the inside. And to show how to make your own library or how to use some precompiled library, I use my D6 Arduino portable version. You can find in another video of the D6 Fitness Tracker. And
It's just the simplest solution to compile your own code for the D6 fitness tracker. So after you download the RAR file, you can just open it and you can directly write your code. And on mine it is selected the right device and the right soft device, but that, as said, is part of another story. And I have here also an example library just to show how it should look. You can build it your own. You can, or you need these two files and the source file. And I will just start by the proprietaries file, and you can open it, for example, with Notepad. And you can also just create it on your own. You make right click and click new text document, and you rename the ending to properties, and it should look something like this. You can find more about it on the Arduino site, arduino.cc. And the important parts are these two lines. First you have to say precompiled is true. That says the compiler that we have some libraries that we want to use. And the next is the LD flags that I will show later where it gets inserted, but here we name the library that we want to include. And the you need the this sign and also an L at the beginning, and then the name of the library itself. But the name of the library, as you see here, is libheart.a, and here it's lheart. And the compiler will delete the L, replace it with a lib, and also will put a .a at the end. So you need to name the file always lib plus the name and plus .a. And in the you just need to write it like this. The other things you just can fill out whatever you want. In keywords you just can describe some names that will get a defined look in the Arduino IDE. So for example the loop is green, or if we write a serial, it is orange, and here you can put some names in you want, and they will get highlighted in the Arduino IDE. Then we have the source code itself. I will start with these two files. Here you need to define a class, which is the library then, and also like here I need to include the arduino.h and also the header file of the library, which is also very important, and you definitely need it so the compiler knows where it looks for some functions. This is the header file from the producer of the heart rate sensor. I found it with the library itself, and it's not edited or anything, it's just put in here, and there it will define every function that is inside of the library and can be accessed from the outside. That is why it is here needed, and also here of course. Then you have the class, and you can define some public functions. For me it's just the library itself, a begin void, and also a get version function where it returns an integer. And here you can also see how it using it. It's just a normal include. Here I also need to set especially for the Heartrate library, that it uses the square root function for the floating points. Because it's not correct defined in the library itself, this will just get over the problem. If you delete this, the compiler will throw an error that it can find the square root function. And here are also two not really used functions, because they are empty, but they are there. It's just to show how it would look. And also the function that will return the integer, and this function will just call the pxelg version function, which is inside of the library we saw earlier. And it's just to show how you would call the function inside of the library. You will find it out. And that's all for these files. I also made some example just to show how it would look like. Just to show where the library itself should go. In this case, it needs to go into the into an extra folder, which is named after the architecture that you are using. So in my case, it's Cortex-M4. And here I put the libhard.a, and there will the compiler search for it, so it can run it, or can use it in the compiling. In the library, not in the library. In the example, I just define the library I show here. I create a class child, and then I will just turn on the serial, print a line, and also I will call the function getVersion that is inside of the library we saw here. It's this one, which will just return the value it gets from the library itself. But it is also possible just to access the functions of the library itself, as in this example. This will directly give back the value that is the library answering from it. So here we to use it inside of the Arduino IDE, we need to edit also the platform.txt. And in my D6 Arduino portable version, you would need to go to portable, and here is the folder sketchbook and the folder library, and there we need to copy the precompiled library example itself into, if it works here. So I will just copy it there, and then it's here. And we need to go to packages also, Sundeep Mystery and hardware and so on, until we get to the platform .txt. Oops, like this. I will open it on another window, and also the properties file where I edited for this, just to show how, and so I don't forget it myself. So we have this line we need to add into the platform.txt. It can be anywhere. I will just add it here. And also we need to add this variable, or this, this will access the variable ldflex that we are defining here. And we need to put it to the line combine pattern that is here. And there we need to put it somewhere at the end. For example, here. It's just so that the compiler also uses the defined ldflex that we created here, and will get used or will get used here. So it's here defined with lhard, as I said earlier. So now we can save it, close all the files like this. And now we can open the Arduino IDE. Oh, I will close this first. And we should have a new library, or a new library and a new example, which was in the library folder, and it's just called basic. And we can now just compile it, and it should compile without any errors. These are just warnings. It compiled it, and it could now be used, this file, to flash to the fitness tracker. I cannot suggest to just flash this file, because then you don't have any way to go to the bootloader. It will destroy the tracker if it's closed. So what I also want to show is how to use the library in a real environment. And for this I edited my D6 emulator code to also use the library, which we looked at earlier. I will go a little bit through the code so you know how it is used. And here it's just defined as in the demo or in the example. I will include the library. We'll make a class, and we need some variables for the library, so the Heartrate data and also the heart rate float, where we can read back the data from the library. And I will try to find the lines I'm searching for. Here are some. Okay. At first we set some variables inside of the library. So we set the mem scale to 0. That's just so we don't use any mems in this library. You could also give the acceleration data, so it can calculate the heart rate better, but it isn't even implemented in the library that I'm using. So I just set it to 0. I enable fast output, and I disable motion mode. That could be enabled if you are, for example, know you are running, then you can set it to 1, and it will make the algorithm calculate that you are running, but that's just not so important. And yes, I know this code is not very readable, but I just wanted to make it so it can be used. I will also enable or disable the sensor, only to have it on while in the menu number 5. So here it will enable the sensor, start the I2C bus and send some I2C commands to the sensor. And if you then press again the touch button, it will just power it off and return the menu. Also here is the code which will read every 30 milliseconds from the sensor, which we can see here. This will read from the sensor itself. Then it will set the MEMS data to 0, the acceleration data, and it will send to the library itself the buffer with the heart rate data that we are getting from the sensor and the MEMS data. It will next read back the signal grade, which is every time 41. I don't know why. It's something broken in the library, I think. Then we will also calculate the integer value that contains the raw value from the sensor. This can also be done without the library, so you just read the buffer via I2C and use this value to read the heart rate data itself. We also have the raw rate then copied to another integer. It's just to make it simpler. So also we now read the heart rate data into the float we defined earlier, and the flag from the process is 0 to 8, I think. And only if it's 0 we have valid data inside of it and we will read it out. Then we can go to display menu 6, which is here, and there it will just print out the heart rate data and the ready flag and motion flag and also the signal grade, just to see it on the display. Here it will also draw the lines, but this is very imprecise now as we have such a big integer value. It's just left over from earlier. The I2C data, I will not go big into it. It will just control the LED, and here it will read out the buffer from the sensor itself. That's all for now. Okay, that's it for this heart rate code which is using the library. I will link it down in the description, but without the library, as I cannot publish it, and you have to find it somewhere else. And okay. So here I have now the code installed on the fitness tracker that I was showing you. And if we switch through the menu and get past the super nice send demo, we will get to the heart rate example, and you can also see that the heart rate sensor is now lighting up, and we can see the heart rate values changing if the camera is focusing like this. These values come from the library itself, and you see the heart rate, you see the flag, and also the signal grade as it is 41, and also the raw value, which is changing a lot, but that's of course normal as the heart rate is pulsing and is changing the value for it or of it. And the line demo, as I said, is not really useful as the values are changing so fast. Okay, now you should know how to use the precompiled library in the Arduino IDE. I don't know how useful it is, and I know that the Arduino IDE is meant to be open source, and it is also my opinion that everything should be open source for it, but sometimes you just have to use some closed source parts. So maybe you want to reverse engineer something and you need to run it via some IDE, and that's the reason I did it. And okay, have a nice day.